Hello, my dear students. Welcome back to the lecture. So, in this lecture, we will see how the slab BBS has to be done, and we'll try to understand that. So, again, I've taken that combined footing. I've taken this particular assignment, okay, and for this only, I'm going to do the this thing. What is that slab? Again, the reason remains the same. The one which I have right now, the this thing, the residential building drawing. If I take, will be not in a position to understand how the reinforcement has to be done. So that is why I'll take this particular drawing first. I'll explain you this one, and once we understand this, next as a kind of assignment, I'll be taking the residential building where we had done the footing BBS and all. As of now, I'll go with this. Okay. Yeah. So again, it's very simple. Slab BBS. See, in this way, the slab is given, and you should remember a few things. In the slab, if it is shown something like this, it means it is a two-way slab. Just in case, if it is shown only one direction, it means a one-way slab. Now, I'm expecting that you know what is one-way slab, what is two-way slab, and all, because in most of my courses, I've explained you all those things. Okay. And if it is written something like this, yeah, if it is written something like this, it means the slab is it's a one-way slab. And what do you mean by this? It means that the load will go in all the four direction. This particular load, this is if this is my slab, and if the load comes on that, this load will be transferred to all the four beams. That is, on this beam, your load will go. On this beam, the load will go. On this beam, the load will go, and even on this beam, the load will go. So when they indicate something like this, it means the load will get transferred on this beam and only on this beam. Got it? So this is one-way slab and this is two-way slab. That's a basic understanding you should have. But again, practically, I always say that practically all slabs are two-way slabs only. But all those things I've explained to you in a more detailed way in my construction methodology course. Right now, it's not required. It's enough for us to do the BBS. This is a two-way slab, and if there is something like this, it is one way. And in this project, if you see, everywhere it is a two-way slab. Okay. Now, along with that, what is the thickness of your slab? That is mentioned here. Floor slab thickness is 160 mm. The thickness of your slab is 160 mm. Roof slab. Why it is written roof slab thickness is 150? That means this particular drawing is for first floor, second, and third floor. Okay. And once you go to the next floor, this is your uh, yeah. Yeah, this is fourth floor slab layout. Okay. This is fourth floor. And I think after that we have one more slab. Yeah, this is fifth or roof floor slab layout. And for this layout, you have to take the thickness is 150. You're getting my point? For first, second, third, fourth, you have to take 160 mm is the thickness of a slab. And since this is a roof layout, it's written here roof floor slab layout plan. Here you are supposed to take the thickness as how much? Slab thickness as 150 mm. Okay, good. This much is understood. We'll go back to that now. Yeah. Okay, fine. I think only this much thing we need to understand. Now coming to the reinforcement part. Okay. Now here in reinforcement, we have two types of reinforcement. One is called as a crank bar. That is you bring a bar like this, you give a crank, you take it in this way. Then you bring another bar like this, you give a crank, you take like this. So this is a crank bar system. A few people use this. But if you're doing a industrial building and all, people prefer to go with a straight bar. That is a cut reinforcement. That means you'll be having a bottom reinforcement like this. Okay, I'll do it like this. See, everywhere you'll have a bottom reinforcement. This is your bottom reinforcement. And in the same way, this is a bottom longer what I put. Then you'll be putting a bottom shorter reinforcement. Okay, you'll be putting a bottom shorter reinforcement. So your bottom reinforcement is completed. Okay, there's a staircase, but still I've taken the bar. Let it be. Okay. Yeah. And after that, you'll be providing the top reinforcement. Your bottom is done. Now, if you ask me, sir, how it's going to look practically, so I'll show you how it will look practically. Okay. So practically, it will look something like this. So practically, this is how it looks. Okay. We'll be doing the BBS for this. That means this is your bottom shorter span. If this is my bottom shorter, we'll put the bottom shorter span all in this way. Okay. And once the shorter span bar are put, we'll be putting the longer span bar. So this will be a longer span bar, which will be put like this. Okay, you can see practically the same thing has been executed on the site. So these are called as straight reinforcement, or you can call this as a cut reinforcement. Okay, fine, very simple. So once this is done, Next, we'll be putting the top reinforcement. So this bottom reinforcement is done. Next is your top reinforcement. So this is your top reinforcement. Bottom is done. After that, wherever you have a support, you listen to my words. Wherever you have a support, wherever there is a beam and a column junction, there you provide top reinforcement. Like see, from here your top reinforcement will come only up to here. Okay. This is your top reinforcement. Here, everywhere it will come. Okay. I didn't draw. It will come like this. And then here also it will come. Okay. Here also it will come. Then again here also it will come. Why it will come? Because here you have beam, here you have beam, here you have beam. So wherever there is a beam column junction, beam usually that will come. Okay, this is your top reinforcement along the longer I have put. In the same way, below this, beneath this, wherever you put this bar, no, beneath that your this distribution steel will go. Okay, you're getting my point? Beneath this, your distribution steel will go. Here also your distribution steel will go. Now, if I delete everything, all of this, you can see practically the same has been executed. See, this bar and in horizontal also it has gone in this way. This distribution bar, you see, this bar also has gone. I'll show you another image. See, practically this is how it looks. Getting my point, right? So practically this is how it looks. So this is your top, this side top, this side top, this side top. Okay. So if you want to see, it will be something like this. See how they are put. This guy is putting the bar. So we need to find the cutting length of all this bar in this way, and then we'll find the number of bars that is required. So this BBS is very simple. Okay, just have to understand the concept. Rest everything is very simple. Okay, this cutting length we'll find, then we'll find the number of bar. That's it. Your BBS will be ready. Yeah. Okay, it will be something like see top they have given no this top, this side top. Now this is continuous support no, so this side also it will come. This side also it is going to come. So in this way, we have to prepare the bar bending schedule. Very simple. I'll tell you what all things you have to do. Bottom shorter, bottom longer. Then along the top, we'll be providing the bar in the shorter and also in the longer direction. You are going to provide the bar. Okay. Very simple. Okay. So it is understood. In this way, you are supposed to do. So first, we'll start with the first bar. So first, what I have done is to make our calculation easy. I have taken this particular area. Only this area I have taken, because here you have a gap. So this is not a continuous building. You have a small gap here, and then this is another slab what we have. Okay, this is another slab what we have. So first I'll teach you to do the bar bending schedule for this particular slab only up to this distance. Okay, that's it. Once this is done, the rest part I'll teach you after that. Okay, this much is understood. Fine. Now for this bar, now here only the layout is shown. They have not shown how the reinforcement will look. For the reinforcement, it is mentioned here. See, first, second, third floor slab, bottom reinforcement. Only the bottom they have shown. Only if I consider only this much part. So this is a slab. So now you tell me which shorter span. So this is 7,500. And yeah. And this is your how much from here to here. What is the distance? 5125, 5125. Roughly it is 10,000. So shorter will be this one. So first what I'll do, I'll put this particular bar first. The shorter span, no, I'll find this. I'll put this bar bars in this way. Okay, I'll put bar in this way. Your bar will be from inner to inner. Okay, inner of the beam to the inner of the beam. This bar will be inner of the inner to inner beam. You have to find the bar in this way. Okay, up to here it is inner. After that, here also will provide shorter span bar. Okay. Then shorter span bar is done. So after the shorter span bar, next we'll find the longer span. Your longer span will be this one. This is longer span bar. Again, this also will come from inner to inner. That is from this beam inner to this beam inner. Up to here. Okay. Similarly, here. Okay. Only these things we are supposed to find. That's it. So this is the only bottom. Your bottom will come like this. So if you ask me, sir, practically how it looks, practically this is how it looks. So this is your complete practical thing. See, all the shorter span, longer span bar will come. Got it? Sure. We'll go back. Fine. And now, other than that, what is the diameter of the bar? Everything is mentioned here. So here, if you're putting a shorter span bar, if this is a shorter span bar, it is mentioned you have to provide a 10 diameter bar at 150 center to center spacing, 10 diameter at 150 center to center spacing. Your shorter span will be 10 diameter at 150 center to center spacing. Now in the longer direction, that is your, again, that is also main bar. Since it's a two-way slab, shorter and longer, both will be main reinforcement only. And your this side bar, whatever we have put, that is also 10 diameter at 150. They have shown no this bar. Okay, that is this bar. Okay, 10 dia at 150 center to center spacing. This much is understood. Great. That's it. So one thing you need to understand, whenever you're putting the bar in the shorter direction, if you're finding the number of bar, it has to be longer direction. So what I'm trying to tell, so if I delete this, I want to, if I'm putting a bar in this direction, okay, I'll put the bar in this direction. This one, 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 this one. Okay, I put no, fine. So how you'll find the cutting length? Cutting length is very simple. I need to find this length to this length. For that, already these people have given me center to center distance. Okay, these people have already given. I'll explain you here only. Next, directly we'll do it on the Excel sheet after that. So these people have given me this center to center distance. How much it is? 747500. So in that, if I deduct this one, in that, if I deduct half of the beam from here, if I deduct half of the beam from here, because I told it has to be from beam inner to inner, but the distance 7500 is given from center to center. Okay. And then from here, if I deduct half of the beam, my beam half is here, half of the beam. Will I not get the clear span distance? Obviously, I'll get the distance from here to here. Now, what is the distance of the beam here? Especially it is 300. So from here 150 I'll deduct, from here 150 I'll deduct, from 7500 I'm going to get inner to inner. And if I add everything, I'll get the cutting length of this. Simple. Got it? Now tell me how you'll find the number of bars. Say 1, 2, 3, 4, 5, 6, 7. How you'll find the number of bar? To find the number of bar, I have to go in opposite direction. That means if you're finding the bar for the shorter bar, you have to go in opposite direction. That is a longer span. So this distance I need to consider from here to here. Okay. Only then I'll get number of bar. So what is the distance given? It is given 5525, 5125. But again, this distance what they have given is from the center to center. But I require clear span because these bars are put from this clear to this clear, right? So again, 5525 plus 5125 minus half beam from here, minus half beam from here. I'll get this particular distance. This clear span I'll get if I do that. And whatever distance I've got, okay. Now, in this, we need to do one more thing. What is that? You can see a beam in the middle. Can you see a beam in the middle? This beam. So you won't put any bar here. Your slab reinforcement will not come here because this is for the beam reinforcement. Getting my point? To put it in a better way, if I can show you that, see here. Yeah, exactly. See, your first bar, for example, this bar, okay? Here the first bar, whatever we have placed, no? Like this bar, horizontal first bar. This bar is not placed over the beam. It's not. These are the beam reinforcement which we already calculated. This is starting from here. This is starting from here. That is why whatever is the width of your beam, no, that we need to deduct. Getting my point? If this is not clear, let me show you one more image for that sake. Uh, yeah, I can show here also. See, this guy is putting the rebar, right? He'll not keep the rebar over the beam. He'll start his first rebar from here. He'll rebar from here. So if I want to find the center to center, if I want to find the distance, then what will happen? Since it's a continuous, for example, if I, okay, I'll show it here only. Let us consider from the beam, from this beam center to this beam center, it was 5125 and 52, whatever it was given. So when you find this rebar, okay, if I want to find the distance, here you have one beam, no? On this beam, is there any bar which is coming? No. So then I need to deduct this beam, isn't it? From this center to center distance, half from left side, half from right side. Like this is my center to center distance. From here, I'll deduct half beam. From here, I'll deduct half beam. From here, I'll deduct half beam. But here in the center, I need to take complete beam size. That I need to deduct. Only then I'll get the clear span from here to here and from here to here. Agree with me? Great. So with this understanding, we'll go back. Yeah. I think where I was, yeah. So that is what one need. So this one half from here, and this middle beam, if I deduct, I'll get the span here. And whatever span I get, if I divide that by center to center spacing of the this shorter span bar, which is 150, written here 150, I'll get the number of bar. Simple. Whatever I did now, if I do it same on the other side, whatever I did now, if I do the same on this side, will I not get the longer direction also? I'll get. That's it. So in this way, my shorter span my shorter span and longer direction, both I'll be calculating. This much is understood, no? If not understood, watch my lecture again. Now here onwards, directly I'll go with the Excel sheet calculation. So this, what is that? Excel sheet already I have prepared. I hope you know to prepare the slab Excel sheet, because slab Excel sheet is similar to the beam Excel sheet. You already done something, shape something like this. Just do a same shape and we'll go forward. Okay. So first I'll go with the shorter span bar. Okay. First I'll go with the shorter span bar. So I've given a shape something like this. Good. So first I'll find the clear span distance. I want to find the clear span. Okay. So for that, we'll quickly do that. So I'll just show here what I'm trying to do. So this is my shorter span. This is my longer span. How do you identify that? You just see the distance. This distance is 5525 plus 5125 is roughly 10 meter. But this distance is already 7500. So whichever is shorter, there your first reinforcement will be placed. So that is why my first reinforcement, I'm going to start from here. My first reinforcement, either you can start from here. There is no hard and fast rule here only. Or you can start from here. So I want to find the distance from this beam inner to this beam inner. Simple. Okay. That is what I'm trying to do now. To find that, I know center to center distance is 7500. From there, if I deduct this beam half the width of the beam from here, and if I deduct half the beam width from here, will I not get this clear span? Obviously, I'll get. Okay. Very simple. See, this is beam. Okay. And this is also beam. Now, what is the size of the beam? What is the width of the beam? That you just have to come here. Okay. That also I'll show you. So it will be written. What we are checking now, we are in the first floor layout, right? So come to the first floor. You have to come to the first floor layout. Uh, so this is, yeah, this is third floor. Okay. So this is first floor beam layout. And what is the width of your beam? See, width of my beam is 300. So this is 300. Everywhere it is 300 exactly. See, everywhere the width of your beam is 300. You don't have to worry. That means half of 300 is 150. 150 from here, 150 from here. I need to deduct. Very clear. I'll not repeat that again. 300 is a width. We need to deduct half from here, half from here. Half of 300 is 150. Pretty simple. So with this understanding, I'll move forward to the Excel sheet now. Yeah, this is what I want. Okay, first slab, bottom reinforcement. Chalo, fine. So I have done the same thing here. See what I have written? 3750 from this center, and 3750 is 7500 minus 150 from here, minus 150 from here. Got it? So this straight length, whatever we got, it is 7200. This much you can do. Good. After that, okay, the straight length I got 7200. From here to here, it is 7200. Now, this is not how you put the bar. The bar will be put something like this. The shape of your bar will be like this. Okay. When you put the slab reinforcement, it will be something like this, like the beam case. It will be like this. Okay. It will be something like this. So I'll show you that on live. See, uh, where it is. We need a end one. So only in the end portion, I can show you that. Okay. Anyhow. Yeah, right now I cannot show you that because it is not there with me. No problem. In the next lecture, if I get a chance, I'll show you. Right now, what I wanted to tell is, see, only in the end portion, if this bar goes, this bar will not go and lie here straight. It will take a bend here. Okay. A small kind of development length will be given. So that will go inside the beam. You have a beam running here, no? You have a beam running. So it will go inside the beam. Okay. That is the shape what you get. Okay, great. That much you can understand. Okay, this end bar will not be straight. It will go and get a small bend here. This small bend will be done. Fine. So now you know all those things how to find. So what I'll do, this is that portion now. This portion I want to find. I'll come here. See. Now with that understanding, your bar will come here. This was my clear span. After that, your development length will start. So this is the development length. Will it go full? No, it won't go full. How much it will go? It will go up to this distance. What will be that distance? Whatever is the width of my beam. From there, if I deduct the cover, I'll get that L length. Okay. So this L length from here and L length from here. This much is understood. But that bar won't be like this. It will bend in this way. It will bend in this way. So I'll bend it. I'll bend this bar like this. Got my point? So I'm just concerned with this length now. I want to find the straight red portion, this straight red portion, and that L shape I want to find. How much is this straight L portion? That we know if because this width of the beam is 300. Wait, this width of the beam, this width of the beam is 300. But this bar we don't keep till the end of the 300. We say we leave a cover. Where we are doing this bar is going into the beam. So the beam cover is 25 mm. So 25 mm cover we are going to deduct from that length. This much you understood? Great. So now, yeah. See what I have done here? The width of my beam was 300. 300 minus beam cover is 25. So this L, the straight portion I got. Got it? Same thing here also. Here I have interlinked here. Again, this side also 300 minus 25 will be how much? 275. This I got. Now, how we are going to find this L? How we are going to find this L? In the beam case, what you used to take? You used to take the overall development length minus this horizontal. You used to get this L, isn't it? This L you used to get. But in case of slab also, you should do the same thing. But actually what has happened in the drawing, what we have got, these people have not mentioned about the development length. These people have not mentioned what is the development length you are supposed to take. So in that case, we can just apply our formula. Whatever is the thickness of my slab, from this slab, I'll deduct the top cover, I'll deduct the bottom cover, I'll get this L. Very simple. I'll repeat once again. In the beam case, these people had told that this is a complete development length. And what we did, we in order to find this one, we used to take the width of the beam, okay, minus the cover we used to do in case of beam. And whatever answer we were getting, in order to find this one, we used to take the total development length minus this would have given us this L. In the beam also, in the slab also, you need to do the same thing. This width we got 300 minus the beam cover I did. So I got 300 minus 25 is 275. But this development length, if they had given in the drawing, then I would have taken the directly development length minus this 275 would have got me this value. Exactly correct. But in this project, they have not given that what is the development length. So sometimes that happens. Sometimes they don't give. In that case, what you do, whatever is the thickness, whatever is the depth of your slab, you deduct one cover from the top, one cover from the bottom, whatever height you get, no, that is the height of this. Simple. Okay, fine. So now, since they have not given it here, I searched in the drawing, it is not given. Few people give, few people don't give. If it is not given, this is how we are supposed to do. And ultimately, you take the decision on the site what you're going to follow. Else, if you have a good engineer on the site, or if your manager says that even though it's not given, in the earlier project, we used to take, let us say, 50 times a day, and this is how we do. In that case, you do accordingly. Okay. But right now, what I'm doing is we are not, that development length is not given to us. So I'll go with this method. Okay, fine. So for this, what you're supposed to do, see, just in case, this is what we are trying to do. Now here also I cannot show you that. Anyhow, that L is not seen anywhere. That L will be actually seen in the corner part because this is all straight, no? If this is a corner, then this guy will bend the bar in this way. Okay, fine. That's it. So simple calculation. What I did is my slab thickness is 160 minus beam slab cover is 20 mm. So from the top 20 mm I deducted, and from the bottom 20 mm I deducted. I got 120 mm. Okay. On this side also got 120 mm. Here also I got 120 mm. Simple. This much you understood, fine. If you understand this, next is number of member 1. What is the dia of the bar? It is given in the drawing. It is a 10 diameter bar. What is given? It is a 10 diameter. Everywhere in this project, you are using a 10 diameter bar at 150. So that remains common. Just write 10 and spacing is 150. Now the important question comes. That is to find the number of bar. So number of bar is very, very important for us. So how you will find the number of bar? So I'll do manually in front of you. To find the number of bar, I have this 5525. So I'll write it here. 5525. Why I'm taking 5525 and not this portion? Because bar is already laid in this distance. Bar is being laid in this way. So if the bar is being laid in this way, we always have to take opposite direction to find the number of members. So my opposite direction this time it will be this one, this portion. So I'm taking 5525 plus 5125. So this will be from where? This will be from this center to this center. But I want clear span. To get a clear span, I need to deduct half of the this I'll explain you only once, rest you have to do. I'll deduct half the beam width from this side, half the beam width from this side. Okay, do that. So what is the beam width? We know beam width is 300. Half of 300 is 150. So from this side 150 and from right side 150. Is it correct? Yeah, we are correct. But still the problem is when you lay the bar, when you lay the bar after this bar, you can see this bar. You don't lay next bar directly on the beam. You don't lay any bar here. The next bar will start again from here. Okay. That is why we are saying clear span we have to take. So that means this beam width is also considered earlier. That means the beam width, this beam width we already considered. This is center to center. No, in 5525 plus 5125, this beam is already considered. But since no bar is being put over there, we need to deduct the size of this beam. And what is the size of your beam? I mean, the width of your beam, it is 300. So we have to take 300. Now it is not half width. If you are doing individually this slab and this slab, it would have been half and half. Then again, it is full only, So that is why you have to take full. What is a full? Full means full width. It is minus 300. Do this manually in front of me and tell me what answer you are getting. 5525 plus 5125 minus 150 minus 150 minus 300. I'm getting 10,050. I'm getting 10,050 meter. So this is a clear span where my bars will be laid. And what is the spacing that we have? The spacing is already mentioned here. You are supposed to provide the bar at 150 center to center spacing. Just divide this answer. Finish. Divide 10,050 by 150. I'm getting 67. We have to round it up. 67 I'm getting. 67, what is it? Numbers. Is it a correct answer? 67. Is 67 a correct answer? Wrong. Why? Because always we have to add +1. Is +1 the right answer? No. +2 we need to do. Why? Because this is one span. If I done for only, see, just imagine what I'm trying to tell. If I done the calculation for only one span, we would have added +1. But here I'm doing for two span continuously. This is one slab. For this slab also I did along with that. That means here also I would have done +1, right? I would have done +1 here, +1 here, and I would have done +1 here also. So +1 is 2 times. So this answer, what I should have done, I should have just taken this answer divided by 150, okay, and then +2 I should have done. So that means 67 number I got actually +2 will be 69 number, and then I need to round it up because always we round up. If it is in decimal point, we usually round up. So the answer should come 70 number of bar should come. How much? 70 number of bar. I'm not sure what I got in the Excel sheet. Yeah, 69 I got. 69. Okay, 69 I got, then it is correct. No problem. Okay, fine. 69 is the right answer. Even though you do round up, you see same thing we have got. Okay, round up will happen only when the decimal is coming. And now in the manual calculation, we directly got 69 only, no? So there's no point of rounding it up again. Okay, so now I've done the same thing. 69 I got. What I've done, you know all these things. Round up, open bracket, 2 times. 5525, 5525 plus 5125, minus 150 from here, minus 150 from here, minus the width of the middle side, minus 300, divided by the spacing. The spacing is 150. Okay, spacing is 150. And what I did, this is very important, +2, because 2 span we are doing continuously. If you had done one first time and this first time, then also we'd have added +1, +1. So 2 times I'm adding +2. Understand the logic of applying +2 here. Actually, it is +1. Since we are taking 2 slab continuously, I'm doing 2 times, so +2. And put that comma, put a 0 and close the bracket. 69 number of bar you're supposed to place. Finish. Your bar bending schedule is ready. Now, I want to find the total cutting length. Total cutting length anyone can do. 120 plus 275 plus 7,200 plus 275 plus 120. Add everything. You'll get the total cutting length. So this is my total cutting length. Now again, in this total cutting length, this is actually cutting length. But since 190-degree bend is coming here, another 90-degree bend is coming here. So 2 times bend deduction we are supposed to do. Now again, bend deduction is totally up to you. I always tell you. If you want to do, apply the bend deduction. I already applied minus 4 into D because 2D is 4D. 4 into 10 if I do, I'll get the answer. If you don't want to do the bend deduction, you don't have to do. You just cancel it out. I'll cancel it now. I'll cancel the answer. This will be answer. Accordingly, they won't be any difference. This is 340 you are getting. And if you do the bend deduction, 338 you are getting. Okay. You're getting my point. So that is the difference. If you want, you can do. Here, I'll do a bend deduction and I'll keep. But actually, the logic of applying the bend deduction is very clear. In the formula or in the drawing, if you're taking anything directly from the drawing, or if you're taking anything directly from the IS code, you don't apply any bend deduction. Bend deduction will be applied whenever you are creating a formula on your own. For example, here we calculated the formula on our own. Why? Because you see, this actually development length was not given. So we took 160 minus top cover minus, this is what we created. It was not given anywhere. This is the way what we practice on the side. So in this case, we have to apply the bend deduction. Just in case if this was not the condition, if we had taken the development length, like the formula in the beam case, it was 57 times the diameter of the bar. In that case, you don't have to apply the bend deduction. Okay. But again, like I mentioned, it's a school of thoughts. People follow their own way. If you want to do, you do it. If you don't want to do, leave it. Okay, fine. Now coming to the cutting length in meter, this answer, whatever I got, you just divide it by 1000, you get 7.95. Total cutting length will be cutting length of one bar, multiply by number of bar, multiply by number of members, will give you 548.55 meter. Simple. Now, I found the cutting length, total cutting length in meter. So I'm using a 10 diameter bar. So how do you find the total weight? So under the 10 table, come here, take the total cutting length of 548.55, multiply it by unit weight of 10 diameter. So unit weight of 10 diameter is 0.617. That's it. Finish. The answer is ready. Got it? So in this way, you're supposed to do the bar bending schedule for the slab. And just now we have finished only the shorter span bar. I'll go with the longer span and then I will finish this lecture and you practice up to here. Now, longer span, can you tell me? It's very simple. Now, I know that you will be in a position to tell me. You directly tell, sir, longer span is very simple. We just have to take this side, sir. Shorter we did, no? So, longer. So, yeah, so longer bar will be going like this, sir. Okay, I'll do like this. Okay, I'll do like this. So, longer will go like this. Very good. You can find the cutting length of this. Obviously, sir, we can find the cutting length of this. It will go like this. Here also it will go like this. Here also it will go like this. Here also it will go like this. Like this. Like this. Fine. Finish. Okay. So cutting length, how you'll find? This from this inner to this inner, if you want to find, you have to take 5525 plus 5125 minus half width from here, minus half width from here. Exactly. And this beam you have to deduct. I mean, yeah, sorry. If you want to find the not that. See, cutting length is very simple. For cutting length, you don't have to deduct the middle one. Sorry for that. For cutting length is very simple. Center to center minus half beam from here, minus half beam from here will give me this cutting length. Good. But other than that, you need to add the development length, that you know how it has to be done. So this development length will not go completely. You will be stopping till the this thing beam inside, right? So how much will be this length? Whatever is the width of the beam, it is 300 in our case, minus the cover 25 mm. Same thing, 300 is up to here, we'll go up to the cover, we'll leave the cover. Cover is 25, so it will be 300 minus 25. After that, this L portion will come. This L portion will come. Okay. For L portion, we know, again, it's not given in the drawing. So whatever is the thickness is 160 minus top cover minus bottom cover. Both side, if you do, you'll get this. Very simple. Now, number of bar, how we'll find? So since we are putting the bar in this direction, now my distance to calculate the number of bar will be this one. From this to this. This one. Right? Exactly. Understood, no? Because bar is being laid in this direction. So that means number of bar, if I want to calculate, I need to take opposite. Opposite of this is this one. So it is directly given 7,500 center to center. So from this, we'll deduct half the beam from here. We'll deduct half the beam from here. Okay. And then again, in the middle, we have to deduct this beam. Got it? Again, for a very same reason, your bar won't be placed here. So in this way, I got the clear span. Whatever answer I get, if I divide that by spacing is again 150. For this bar, it is mentioned here. See, 10 diode 150. 10 diode 150 this way. So if whatever answer if I get, if I divide it by 150, will I get the answer? You will get the answer, but it is wrong answer because we need to add plus 1 here and you need to add plus 1 here. Plus 1, you need to add plus 2 and you'll get the answer. Finish. This much you can do. The same thing I've done it here. Come. First we'll find the cutting length. Cutting length, how we'll find? 5525, 5125. Same thing I've written. 5525, 5125, minus 150 from here, minus 150 from here. Done. So this will be 10,350. Rest this and this will be equal to this one. You just copy it. You just select here and interlink this. Select here and link it. Select here and link it. Select here and link it. That you can do. Fine. So you have to name it here longer span bar along the grid. Okay. So you write what grid it is. Okay. Here I've written shorter span main bar. Here longer span. It is again main bar only since it's a two-way slab. Longer span main bar along the grid. Which grid we are doing now? You have to write. So longer span we are placing along the grid. Along ABC grid, laying in 1, 2, 3. You have to write along ABC grid. Along grid ABC. Okay. Along ABC. So along ABC, it's enough. If you want, then you can write laying in 1, 2, 3 direction. Else it is okay. Okay. Or you write placing in 1, 2, and 3 direction. Okay. Now it will be this thing. You just reduce the size of. Okay. Fine. Good. Now this will be number of member will remain same. Dia will remain same. Spacing is also 150. Now coming to the number of bar, we have done. See, round up. Always you have to do round up whenever you find the number of bar. Round up 7,500 minus half width from here, minus half width from here. So minus 150 minus 150. And in the middle, we had this beam, no? Middle, this beam also you need to deduct. That is 300 minus 300. Close the bracket, divide by the spacing. Spacing is again 150 plus 2 I have done because 2 span I took. I took this span, okay, and this span. Now you don't tell, sir, your bar, you see, there may be few students who may tell the bar is being laid in this direction, but span, sir, we have 4, no? See, span is only 2. Don't consider this is 1 span, this is 2 span, 3 and 4. No, this complete thing, when you come here, you'll be adding 1 plus 1 here, plus 1, only 2 times, okay? Okay, chalo, finish, that's it. So if you do that, you do it, you'll get 48 number of bar. And total cutting length, you add everything. 120 plus 275, 10,350. 275, 120 will give you 11,100. Again, you need to check whether the distance is greater than 12 meter or not. If this distance was greater than 12 meter, we should have given a lapping. But here, this distance is less than 12 meters. So one straight bar is enough to take care of this particular thing. Okay, fine. So total cutting length will be 11,100 divided by 100 will give me 11.1 meter. So total cutting length will be 11.1 into number of bar is 48 into number of member will be 532.8. And then this is 10 diameter bar. So cutting length I got. So weight will be 532.8 multiplied by 0.617. This will give me the weight of my steel. That's it. Got it? Great. So in this way, what we have done, we have finished our bottom reinforcement completely. This particular area, bottom reinforcement is done. Your BBS is ready. Your BBS is ready for this complete span. Only the bottom reinforcement we have finished. Okay, if somebody comes and asks you that tomorrow we have to place the bottom reinforcement for this slab, only the bottom we are going to place tomorrow, and today I need to order the steel. Can you tell me how much steel is required? Just do the calculation, and this calculation I'll do it here. This answer plus this answer. You tell them you require almost 700 kg of steel, and that to 10 diameter, so that he can call the hardware shop or he can call the vendor and say, I mean, I'm giving an example. Now, just you don't call for 700 kg, you do every estimation and accordingly you plan. But I'm giving just in case somebody came and asked you, you tell 700 kg of steel is required if you want to do your bottom reinforcement of this particular slab panel of this 10 diameter having 150 center to center spacing. Now, the power of Excel sheet is tomorrow if something happens, instead of 150, your consultant told, no, 200 we will do it. Finish. Answer is ready accordingly. See, instead of 150, if it is 200, see the answer. It has come down to 513 kg. Spacing increased, the number of bar came down. But again, we'll keep same thing. Accordingly, everything changed here, okay? Diameter, total cutting length also change, weight also change. Finish. But I'll keep 150 only, just to make you understand. Yeah, that's it. Finish. So, I hope you have enjoyed my lecture up to here. So in the next lecture, we'll go with the top reinforcement. So in the top, we'll be having a reinforcement. We'll see how the top reinforcement is to be put. So in this way, the top reinforcement will take care, right? So we'll see you back in the next lecture. Thank you.